Hello and welcome to this webcast. Today we're going to be talking about best practices in oil and grease analysis. In most cases, people are used to thinking about results of an extraction in terms of target compounds with specific chemical compositions, something like naphthalene. In this case, though, oil and grease is characterized as a method-defined parameter. For the purpose of this discussion, oil and grease is going to be any compound which is extracted using N-hexane and measured gravimetrically, including things like soaps, hydrocarbons, and some forms of dyes. The measurement of oil and grease is applicable to a wide range of industries and matrix types, and as I said, the measurement of oil and grease is applicable to a wide range of industries and is used to determine everything from soil or water contamination to the health of a sewer system or a wastewater treatment plant. When we talk about oil and grease in the U.S., we primarily are talking about the NPDES, the National Pollution Discharge Elimination System, in which we regulate the amount of this substance which can be released into the environment. However, other regulated areas such as the testing of underground storage tanks or petroleum exploration may also use this technique, even if it's just to screen the samples prior to running a more complicated form of analysis, something like a GCFID. As I know that we've got a rather diverse audience, I don't want to spend too much time going into the U.S. specific regulations. Suffice to say that U.S. law specifically governs the level of oil and grease which can be discharged into the environment. As an example, this chart shows the effluent limits for oil and grease in the processing of catfish. The roots of oil and grease are a little diverse in that it comes from one of three different types of methods. EPA method 418.1, standard methods 5520, or ASTM D7066. All of these methods worked wonderfully, but they made use of various solvents which were known to deplete the ozone. And under the Montreal Protocol, the use of these ozone-depleting solvents became prohibited. So in the U.S., this spawned a search for a test which would produce similar results to the old methods, but use more friendly solvents. One whole type of solvents was eliminated early on, the chlorinated solvents, as there are too many health and disposal concerns associated with them. This search was concluded with the promulgation of method 1664. This method uses N-hexane as an extraction solvent and, through testing, was shown to produce similar results to the previous methods. Since then, there's been two revisions that have followed the original one, each seeking to clarify points within that method. More internationally speaking, a host of other methodology based on this method 1664 were developed or revised to test for similar components. And of this method shown, standard methods 5520 and the ISO 11349 are pretty close, if not exactly equivalent to method 1664, while the other three listed require a more complicated analysis such as GCFID. No matter what method you're running, we can pretty much guarantee that the technique will end up being audited as part of a quality control process. This audit process almost always creates some clarity, but also some confusion regarding specific requirements that are written inside of the 1664 method. And this is what we're going to focus on for the rest of the presentation. Because the number of different industries which are required to test for oil and grease have so many different waste streams, the types of sample matrices which end up being run vary a lot. Not only the solids content, but the actual waste stream itself, whether it's salinated or whether it's some form of industrial waste. The images that are shown on this slide are actually some samples that I've run personally in the past, specifically using an automated solid phase extractor. Historically, the extraction procedure uses a separatory funnel to serially shake an aqueous sample using N-hexane. More recently, many users have converted to performing solid phase extraction, or SPE, which filters the sample through a solid phase disc and then elutes from that disc using N-hexane into a collection vessel. So to start our audit topic discussion, the first thing I'd like to talk about is method equivalency. And while the 1664 method, revision B specifically is what we're going to talk about today, says that you can use SPE, there's been a lot of questions regarding demonstrating a proof of equivalency between liquid-liquid extraction and solid phase extraction. In revision A of the 1664 method, most users were required to prove that the SPE procedure worked for their particular waste stream. So most people will have the question, do you have to do this for every waste stream, prove equivalency that is, in revision B? Well, let's start by just examining what's needed to prove equivalency. Most cases, you're going to have to run an IPR, an initial precision and recovery test, and determine the MDL, a method detection limit, which is not really a big deal. But if you're going to use the data for compliance work, in revision A, you would normally need to run a matrix comparison for each waste stream. This last step could turn out to be really burdensome, especially for those of you who are commercial facilities out there. You might have 10 customers, each with 10 different waste streams. You'd all have to prove equivalency. So the question is, do you still have to do that even though we're on revision B now? The good news is that the method specifically says that any of the modifications given in section 1711 are exempt from having to run this equivalency study on waste streams. Since SPE is written in there, we're good. You don't have to do it. Now, that's not to say that you still don't have to run that IPR and the MDL. Those are still required and are part of a good quality control program. So if you are determined, since we've determined that you're allowed to run SPE, but an SPE vendor lists methanol as one of the solvents, and if you're reading the method and you catch up on section 172 that says unacceptable modifications, it says that you can't use co-solvents. So why would the vendor even suggest this? And is it okay if you are using a co-solvent? Well, the reason that most SPE vendors use a water-soluble solvent in the extraction process is to remove residual water from within the disc or cartridge. So if you think about it, we're going to take an aqueous sample which has a bunch of leaves and dirt in it, and we're going to filter that through a disc. Then we're going to squirt hexane on top of it and just expect the hexane to go through the water, the polar phase, to be able to get to the target oil and grease. Because of the polar-nonpolar interactions, you're going to have poor recoveries. So if you look at this slide, the top section illustrates how your sample is going to come down, and some of your oil and grease targets are going to be encapsulated by this water. When your hexane rinse comes in and rinses off that SPE disc, you can see you're only going to get a fraction of the total recoveries. If we build in the methanol step that we're going to call a discard step, we'll break through that encapsulation of water, and then we'll be able to rinse off any of the remaining target analytes. As a proof of concept, Horizon took and extracted a set of samples from a local wastewater treatment plant, one with methanol and one without. And what we found was that if we didn't use methanol, we had a 42% loss in analyte recovery. Now, that's all well and good, but if the method itself specifically says that you can't use methanol, then we're done. So what do? Well, to come back around to that question, the answer is that you're only out of compliance if you're using co-solvent as an extraction solvent, meaning you let the co-solvent go into the final extract. If you use the co-solvent as a wash step, discarding it, sending it to a waste stream, that's fine. The caveat, though, is that the individual lab has to prove that there's no co-solvent left on the disc to interfere with the results. So how do we prove that there's no co-solvent in that final collection vessel? In the method, there's a procedure given where we take a dry SBE disc, we record the weight, then we process a blank through the disc and dispense the polar solvent. We then air dry the disc, collecting weights at set time intervals until the final weight and the original weight are within 101% of each other. Now, while this procedure makes sense, the problem is that there are a lot of interferences which are introduced to the disc in that time. There are other solvents, and we're doing other types of things to the disc before we get to that co-solvent wash step. In testing that we performed, this technique that was outlined in the method ended up taking more than an hour for the disc weight to drop to 101% of the original weight. Instead of waiting that long and following that specific procedure, what we suggest is that the user process a blank, but take the tare weight just prior to the polar solvent being dispensed. Once the polar solvent is introduced, then dry the disc using the same technique as outlined in the method, measuring the weights at set intervals until the weight is 101% of the original weight of that disc that was taken just before the co-solvent was dispensed. This technique takes only 2 to 3 minutes. Another thing to note is that the procedure that is outlined within that method is given inside of a note. It's not given as a requirement, it's just given as a suggestion for a technique on how to perform this. So we're not going to be in violation of any method as long as we are attempting and proving to auditors and to ourselves that the co-solvents have been removed. Further, you might expect to hear some SBE vendors say that they don't use methanol at all, and that's how they get around this whole co-solvent issue. But I would challenge those people to run a wastewater sample side by side on an SBE procedure and a liquid-liquid procedure and to publish those results. If that disc has a lot of other organic content on there, you're going to have a lot of water acting as an interference, and then your recoveries will certainly be low, or the process will take an excessive amount of time. Once we've established the extraction technique, the next step is to start talking about spiking. The method itself calls for 20 milligrams each of hexadecane and steric acid to be added to the sample for a total concentration of 40 milligrams. But for those people who make their own standards or who purchase a vial containing multiple aliquots, it's convenient if you could spike less so that the cost per sample decreases. With this latest revision, according to the method, this is fine. Another topic that frequently comes up is, in the past and even now, what we normally tell people is that smaller diameter SBE discs can be used for clean samples, while larger diameter discs can be used for dirty ones. So can you use a 47 millimeter disc for clean QC, the quality control samples, and a 100 millimeter disc for dirtier samples, all within the same batch? Simply put, the answer is no. If you're going to use a particular brand and size of disc, you need to stick to that throughout the batch. You should also be aware that with the latest revision, they actually specifically require you to have a set of control charts for each brand and for each size of discs that you're using. But what about pre-filters? A lot of samples that end up getting run have some sort of solids content to them and end up needing pre-filters. So if you use a pre-filter for one sample, do you have to use it for every sample in that batch? Remember, the goal here is to filter that aqueous sample through a disc, and most of the discs that are out there are about the same thickness as a penny. If we use only an SBE disc, odds are good we're going to have some trouble. Most vendors have some techniques for running dirtier samples involving the use of pre-filters. This is a diagram that I use to illustrate to some of our trainees on proper layering technique and how the sample would flow through it. If done correctly, then the result is a smooth flow of sample through an SBE. This is Horizon's newest oil and grease extractor, the SpeedX 3100. Those are samples that, well, the method itself allows for pre-filters to be handled on a sample-by-sample basis, just like traditional emulsion breaking techniques. So what I mean by that is, let's say you've got a particularly dirty sample, you're running it on liquid-liquid extraction, and you form an emulsion. Most of the time, you'll employ either adding a bunch of solvent to it, or one of the more common ones that I've seen is you end up centrifuging it, but you don't go back and you don't centrifuge the entire batch. You just do that one sample to break the emulsion. Pre-filters should be treated exactly the same way. You can use them on a case-by-case basis. But what happens when pre-filters aren't enough? How much sediment can you run using SBE? Usually this comes from someone who has tried cartridge SBE in the past and remembers all of the problems that are associated with that. Processing time here will depend on a lot of things. Mostly, if I was to classify it any one way, I would classify it in terms of geometry. It means that the volume of the disc holder, as well as the shape and type of particulates that are being loaded into the holder, all matter. Obviously, rocks being put into a disc holder aren't going to slow your flow rate down at all, whereas really, really fine particles will. So what do you do if you have a sample and there's too much sediment in it? The simple answer is to reduce the sample volume that's being run. The method in its latest revision allows specifically for smaller volumes to be collected when a complex matrix is sampled. The caveat to remember here is that whatever you collect, you have to run. So remember that these are grab samples typically, and if you're going to grab a liter, that 1 liter is what you have to run. Now, it's all well and good for me to say reduce the sample volume, but for at least, I believe the number was 25% of the people who were on here from commercial labs, you may or may not control who's doing that sampling and what the volume is that they are sampling. You might just get this in on your dock and be expected to put a number out. So what do you do if that sample that you receive in won't flow or has too much sediment in it? The answer is to split the sample into 2 aliquots. What you're going to do is split that sample, extract them both, and then recombine them at the end of the process to get one reportable number. Since you're going to end up running the entire sample, you're still going to rinse the original container and the cap. There's not going to be any breach of the method there. You are running the entire sample and extracting the entire sample. The nice things about some of the systems that are out there is that the original sample can be rinsed automatically. Watch that first bottle there. There you go. You see that it is rinsing what would presumably be your original sample container automatically. One of the things that automated systems don't do typically is automatically rinse the cap. So because the systems don't automatically rinse the caps, some users assume that it's not important. However, they would be wrong. Why is it important? Well, it's important because if you think about the type of matrix that we're getting in, and the target analytes in this case being oil and grease, oil floats on water. So if you don't rinse that cap, you run the risk of not getting a full extraction and actually misrepresenting your sample. So let me give you an example. A few years ago, there was a company that was selling proficiency samples that had vacuum pump oil rather than the hexadecane and stearic acid mix that we typically use for our LCS style samples. When you would get calls, the underlying problem for low recoveries would end up being not rinsing this bottle cap that was received in. And we could see impacts in the final recoveries as much as 10% or more in some cases, depending on how bad that cap was coated. I think everybody gets the importance of why you would need to rinse the cap, but the other thing that needs to be mentioned is the technique for how you're going to rinse that cap. Most older instructions, including some instructions that come in with proficiency tests even now, tell users to rinse the cap with hexane and then put it back in the bottle and then extract the sample. Well, the problem with that is that the hexane will actually partition some of your oil and grease analytes out of the water into the hexane phase. So in essence, doing an extraction within the bottle. And then when we filter the sample in SPE, both the hexane and the water go directly to a waste stream. So for liquid-liquid extraction, it's fine. You can rinse the cap and put it in the extraction vessel. But for SPE, you don't want to put the rinse into the bottle, but rather you want to wait, and after the water sample has been processed and you are rinsing the disc to collect the final extract, you want to rinse that cap at that stage and include that in the disc holder. That way you'll be sure to capture all of your recoveries rather than potentially sending some of your targets to waste. Now with the extract done, time to talk about drying your sample. There's a lot of variations on this technique, from sodium sulfate to solvent phase separation paper to different forms of membranes to some people who just use a small separatory funnel and drain off the water, or use a pipette and drain off the water themselves. Recently, I believe it was last year, a document released, actually it was in August 14th of 2013, Arizona released an update and featured a quote from the EPA stating that all of the techniques listed on this slide are acceptable except for careful pipetting or draining of water. So if all the extracts have to be dried, most labs are already familiar with sodium sulfate and will just incorporate that into the process because it's cheap and easy, right? Well, when you look at the analytical technique, at the end of the day, we're going to be using a balance to weigh the final product. And there's an awful lot that can go wrong in this case. You might be using a pre-packed cartridge that doesn't have enough sodium sulfate in them and lets water get into your final weighing vessel and gives you a false positive on your results. You may not seat your filter paper correctly, and fines will get through and inflate your results again. Or you might not rinse down the sodium sulfate at the end of the process sufficiently, and you might lose some recoveries due to absorption onto the particles. All these things point towards sodium sulfate being more complicated than at least most users think. The easiest way that I've found to dry extracts is to use a membrane to physically separate rather than to chemically separate the water from the extract. Now, with the extract being dry, we're ready to distill off the solvent. One of the big points of contentions with the solvent distillation is that a lot of users have been told by auditors and by others in their companies that they have to use 70 degrees C because that's what the method states. However, this high of a temperature made it so that by the time the vessel looks dry, it's already too late. And they've lost their light end recoveries and they end up with lower recoveries. So what do I mean? The temperature setting on any one of the devices that could be used controls the speed of the evaporation. To get the process to go faster, a lot of users will turn up the temperature. But what happens when the analyst looks away for just a second? All the hexanes evaporated, all the light ends of the targets, specifically in the case of an LCS standard, it's hexadecane, are being lost. Conversely, if we turn the temperature down too far, the process ends up taking too long and we're simply wasting time where I could be doing something else. So what do we say about the temperature is that it's a very fine line to walk between a faster turnaround time and the possibility of recovery losses. And the important thing to really note about it is that the temperature is up to you. As long as you can pass all the QC, then it's fine. Now, once you're done getting your extract and getting all that solvent distilled off of your vessel, and you pull your vessel from the heat source and you take a weight. Some people will assume that they're just done. The method states that you should take repetitive weights, but is that something that you really have to do? Well, when you remove that vessel from the heat source, there's still some residual heat that's retained in the vessel, which needs to dissipate. As that heat dissipates, the weight of the vessel with the extract will change slightly. If we remove it from the heat source too late and all the solvent is gone, any temperature change that is going to happen to that pan is going to be facilitated by the standard evaporating off your lighter compounds. This is why we pull the vessel prior to full solvent evaporation. That way the heat will dissipate as the solvent evaporates. So this should make the need for the process of repetitive weighing a little bit more obvious to everybody, since even if the pan appears dry, there may still be some solvent which is evaporating from the pan. You may get down to the end of the process and the whole pan may look dry, but it might take you another 10, 15 minutes to get to a point where the weight has stabilized to within the criteria dictated in the method. So do you have to take repetitive weights? Absolutely. By sampling multiple times, you're going to be more certain with the results that you get, and you'll be more certain that that is the true final value. As for how long you should wait between measurements, the method itself says 30 minutes, and that's what I would go with. So there are a lot of different things to consider when you're setting up to run the 1664 method. And it's very important to pick the extraction, drying, and concentration techniques that allow your facility the most flexibility for the types of samples that you get in. If you think that most of your samples are going to end up forming emulsions, maybe you should consider SBE. If you think that your staff are better equipped to use separatory funnels, then go with liquid-liquid. At the end of the day, what's most important is how the technology is going to work for you and how well your people are going to be able to assimilate that technology into their daily lives. Thank you, and there should be a question and answer period, so Alistair, I'll turn it over to you.
That's great, and that's correct, David. There will be a question and answer session, and I'd like to remind the audience how to submit questions. You can submit questions by typing them in the Q&A box, which can be found by clicking on the red Q&A widget at the bottom of your presentation window, and we'll try to answer as many questions as we can. And the first question, David, is what is better to use, glassware or aluminium pans for evaporation?
So I prefer the aluminum pans. The main reason is that they cool off much faster than glassware. Remember, glassware is basically a crystalline matrix, so when you heat that up, it's going to take a lot longer for all of that to cool down. So when you pull whatever your vessel is off of the heat source, even if you have more than enough solvent to facilitate a heat change, I would still be more suspicious that I might lose some of my lighter end compounds due to the glassware retaining heat longer than the aluminum pans. So I would stay with aluminum pans.
Okay, thank you very much. And we have another question, which is, how long does it take to extract a sample using an automated system?
So this can be a little tricky. For DI water to extract, the process generally takes about 20 minutes using an automated SBE system. Now, when we start talking about dirtier samples, the time starts to increase, specifically how long it takes to filter that sample. Generally, most samples are extracted in 20 to 40 minutes. One of the things I would say, though, about all this is that as the time increases, this is when our training kicks in and we start to really examine the types of pre-filters that were used or the sample volume, and this is all handled when, at least by Horizon, at the point of installation, we do a training procedure to talk about all of these things.
And the next question is, exactly how does one use a membrane to aid in the drying of the extract?
So there are a bunch of different kinds of membranes out there, but at the end of the day, usually what they are is it forms a physical barrier based on the porosity, the pore size of the membrane. And what you'll end up doing is applying a vacuum on one side of the membrane and putting your sample extract on the other side of the membrane. And the way that they work is based on the fact that they're slightly hydrophobic. The water, any residual water, will be left on one side while your extract will be dried and pulled through onto the other side of the membrane. In some cases, these can be standalone. In other cases, they can actually attach to whatever the extraction apparatus is that you're using.
And next question is, can it be used for fatty acids?
If we're talking about like FAME analysis, fatty acid methyl esters, generally we tend to go more towards GCFID type of analyses with that because the extractions, I believe, use some form of dichloromethane. So no, not normally, but it really depends on what we're talking about. I guess we could do some sort of fatty acids with this particular system, but it just depends on the level of analysis that we're looking for.
Okay, thank you. And the next question is, do you have any suggestions for suppliers for pre-filters?
So for pre-filters, obviously I'm going to say Horizon because we sell our own form of pre-filters that go along with them. There are a lot of different types of pre-filters out there. The big thing to note about pre-filters is that there are a lot of different pore sizes. For the types of samples that we generally talk about with this particular method, you do not want to select one that has a very small pore size, or else you're just going to plug the pre-filter that you're using. So in general, I would say just verify that the pore size is sufficiently large, 5 micron or more, and then you're going to have to do some testing with them to make sure that whatever method you're using to extract them is fully optimized to use those pre-filters.
Okay, and someone wants to know, does the methanol wash never remove any of the new target analyte?
It may remove some of the target analyte, but most of the time when you're talking about doing a wash step, especially, so let me give you from the perspective of me having been in applications and having written these methods, the reason and the location of that wash step is specifically chosen. When we're doing method development, we will move that wash step down through the process. So it's not just one rinse of hexane and one rinse of methanol and then another rinse of hexane. We will actually do 3 or 4 rinses of hexane first to collect as much of what I'll call the free oil and grease as possible, and then we'll do the methanol wash step. And then after that methanol wash step, once the water's been removed, we'll go back in and clean up any residual oil and grease that we may have uncovered in the process.
Okay, and is drying off the solvent in an oven permissible?
I would not put this in an oven, specifically because, well, for 2 reasons, really. If there is a high concentration of hexane vapor in that oven, and the oven is a closed chamber, it might turn into a bad situation very quickly. Hexane vapor being flammable. The other thing is that it generally doesn't take that long at the end of the day when all of the solvent is gone for you to get to a stable result. The better idea for it to make sure that you're getting down to the right point, if you're talking about the distillation process, is maybe something that provides a little bit of heat from the bottom and maybe some form of a sparge from the top, some sort of a gas flowing over the top of it. It'll give you a nice cooling feature and give you a much stabler, much more stable evaporation rate. And then when you're done with that, if you're going to store it for any prolonged period of time between weights, use a desiccator.
Okay, and someone else has written that my samples contain much turbidity as it's refinery waste. Is there any steps that should be taken in this sort of circumstances, David?
So there are a couple of different things that you can do, but almost all of them require fall back on the pre-filter ability of it all. If you find out that the turbidity is too high, then I would definitely look at reducing your sample volume. That's really one of the key methods for handling these really complex matrices, is to just reduce the volume the next time you're doing it. If you can't reduce the volume, then certainly split the sample into 2 or 3 aliquots. And the best option I can give to anybody who's trying to handle one particular sample, a lot of times you'll be able to request from whomever is sampling this, request a duplicate. And I don't want to call it play because we all work for a living, but play around with that particular sample, test it, and try a couple of different pre-filters on it and see what works. And once you find out what works, the big thing is to write it down. Make sure that you make notes of it, because if you're going to be out and your assistant or your coworker has to take over and run that particular sample, then they'll already have a hint at what you did. So historical analyses can be great.
Okay, and someone else wants to know if they can use a solvent mixture of hexane and tetrahydrofuran.
I don't know that you can use tetrahydrofuran, especially on our extractor, on Horizon's extractor. For the 1664 method, the answer is definitively no. Because oil and grease in this context is declared basically a solvent-defined analyte, meaning the recoveries have to specifically do with anything that is extractable in hexane. Adding another solvent is going to be strictly prohibited for anything that's going to be done within the U.S. per the NPDES permitting.
Well, thank you again. Someone wants to know, how much N-hexane do you suggest using for the elution step?
Typical volumes for most SBE are somewhere between, I believe, 80 and 100 milliliters for larger sized discs for SBE. For smaller sized discs, I believe it's closer to like 50 or 60 milliliters.
Okay, thank you again. And how does the spike recovery come out on samples with a bad sample matrix?
So you may always see some form of a matrix interference, but it really depends on the type of matrix that you're seeing. Ideally, when you develop the methods for use in your particular facility, you will take into account the dirtiest samples that you have and attempt to make your method work for those samples all at the same time, and this includes when you're doing a matrix spike. Now, because you rotate through matrix spikes and you rotate through waste streams for your matrix spikes and your matrix spike duplicates, it might not always be the case. Sometimes, you know, if you're sampling from location A, the matrix might change based on the amount of rainfall that you've had in that particular week. Or maybe the food processing plant that you're getting it from has changed a chemical inside of their process, and you won't necessarily know about it until you can get to that matrix effect. And one of the nice things is that the method and most EPA methods actually specify and allow you to flag it as a matrix effect, provided that your DI water blank or your DI water spike is fine.
Okay, and if someone says they do have like a 3000 XL extractor already, should they increase the methanol time volume if a disc isn't getting fully wetted with the current volume?
Yes, you certainly could. So a lot of the methods that we put out, or in fact all of the methods that Horizon puts out, are designed to work at our facility, which is in New Hampshire in the U.S. Depending on where you're located geographically, if you go up in altitude, if you're in a really humid climate, you may require some form of method modification. One of the things that I could see is that if you're adding pre-filters into there, you may need to add, or I should say, if you're adding pre-filters in there, or if your sample is got a lot of content that is being dispensed onto that disc holder or into that disc holder, then you may need to customize the method. But if you're going to increase the methanol in that step, I would make sure that you increase all of the hexanes that happen, all the hexane rinses that occur before that too. You want to make sure that you get the majority of the free oil and grease off before the methanol wash step happens.
Thank you again, David. And how much hexane is used for one sample using solid phase extraction?
So it really depends. If you're talking about clean samples, you may be using anywhere from 50 mils to 60 mils per sample. If you run with a larger size disc, then you're going to need more to elute that off, and that's more around the 80 or 90 milliliters of hexane being used. If you, as the previous question stated, if you choose to modify the method, you can actually make it dispense more or less. It just depends on what your samples require and what your requirements as a facility are.
Okay, thank you again. And do you suggest doing one elution step or multiple?
Always multiple. And the reason for that is So let's make a metaphor with construction. You can take and hit a nail in with, you watch the people who do it all the time, and they can use a hammer and hit a nail in 2 hits. But for those of us who don't do that for a living, it may take multiple hits. Sometimes when you're trying to do something difficult, if it's something like you're driving it through a particularly hard wood, even the professionals slow down and take multiple hits at it. Same thing happens here. You don't want to just assume that one rinse is enough. Sometimes it's the impulse. It's the impact of taking whatever rinsate you're going to use and rinsing everything down multiple times that gets you the full recovery. This is why all of the methods that are out there, no matter if it's liquid extraction or solid phase extraction, why there's always multiple. We don't just do one shake of hexane with our sample and assume we've got all the recoveries. We do at least 3. So I would say multiple always.
Okay, thank you. And another question, David, is if pre-filter is required for the sample, is it not required for QC samples like blanks?
Exactly. So one of the things that we went over earlier in the slides was that pre-filters were to be treated on a case-by-case basis. So let me see if I can find the slide. We'll pull that slide up. So if you look, I believe this should change. So in section 1718 of the 1664B method, it gives you permission to use the pre-filters for just that sample rather than to use it for the entire batch. Most often, when I've done this in the field, it's been, I'll get 5 or 6 of the samples pulled, and then the other 10 samples come out later. So you may not know that you necessarily need to use the pre-filters until that sample comes up. And I think that was kind of where all of this was going. So remember, the pre-filter usage is kind of like breaking an emulsion. You don't necessarily need to do it for every one of the samples in the batch. As long as you're following good techniques, you should be fine.
Okay, thank you very much. But I think that's us running out of questions. But someone has asked if they can receive a copy of the presentation, and Horizon Technology can send you a copy of the presentation after the event if you want to see it, because it has been a very useful presentation, and there was a lot of useful information in there. But unfortunately, we're out of time. I want to thank the audience for their interesting questions and participation in today's event.